So again, I'm going to try and match basis. 6 to the negative 2k, 6 to the, well, I can't do that, but I know that 36 is 6 to the second, right? 6 squared. Okay, so that's great. And then, well, if the bases are equal, then I know that the exponents are equal. So I'm just going to have negative 2k equals 2. Has to be true. All right, divide by negative 2. K equals negative 1. There we go. Now, what happens if I plug in negative 1 to the original? Well, I get K, which is negative 1. Negative 2 times negative 1 is positive 2. Okay, 6 to the positive 2 is 36. That works. There we go. Easy. I'm going to do another. Now here, I'm going to solve, and I'm going to try and match bases. And I see that there's a 4 here, so can I write 64 in some way? 4 to the something? Let's see. 4 to the, well, let's try 4 to the third. 4 times 4 times 4. Does that work? And it sure does. 4, let's do it in blue. 4 to the third. That's the same thing as 64. And I still have this n on the outside. And that's equal to 4 to the 3n. And then power of powers, I multiply. That's that same rule as in the first video. So then 4 to the 3n equals 4 to the 3n. Well, those have to be equal, so 3n. Once the bases are matched, we can say 3n equals 3n. If I subtract it to one side, watch what happens. And it goes away, and I just get 0 equals 0, which is true. And in fact, it doesn't matter what n value you plug in. If I plug in 0 here, I get 1, right? If I plug in 0 here, I get 1. If I plug in 1 here, well, 64 to the 1 is 64. And then that becomes 3, so I get 4 to the third, which is just 64. So this actually, it works for all real numbers. Anytime you get 0 equals 0, it's all real numbers. And there you go for that. I'm going to do another example in a different video.